Okay, so welcome. This is cloud computing. My name is Vasilios Adamos. You can just call me Vas. Yeah. So in this module, we'll deal with uh, cloud computing. We'll build ourselves a nice little cloud, and we'll learn everything that we need to know about cloud systems in general. Okay. I'm sorry about the mix-up with the rooms. It was a problem with the timetabling. We're not going to have our next lectures here from next week onwards. It's going to be somewhere on Anglesey building because that's where the lab is as well. And you will have a lab session with me on Friday as well that lasts 3 hours. So you will either be in the morning session if you're on the computer science and cybersecurity courses, or you will be in the afternoon session with me if you're in the computer network administration and management course. Okay, so we'll have our lab on Friday and we'll have our 1 hour lecture on Friday as well. So you don't need to come to university for this module more than one day. Okay, so what we're doing is this module mostly runs in A2.NET. So it's our computer networks lab, which is in Anglesey building, second floor, all the way to the left as you go up the stairs. And my office is in A202B, so that's Anglesey building again. But you'll hardly ever find me there. If you do find me somewhere, it will be in the lab in A2.NET. All right. And if you need anything from me, the best thing to do is just send me an email and ask me whatever question you want to ask me. So, the unit itself, so we'll have weekly 3 hour lab sessions and weekly 1 hour lectures. So during our lectures, I will explain all the theory that we need to have, that we need to know for you to be able to complete the lab sheets. And in the labs, you will complete the practical work on your computers and basically learn by doing. I'm not a very big fan of death by PowerPoint. I don't like it. So I usually prefer to go through the lab sheets and explain all the theory and all the details behind them in the lecture, as we do here, and point you to sources so that you can study some more if you need to, and then you learn by trial and error, basically, in the lab itself, which I think is a better way for you to learn. The assessment of this module is 50-50, so we have two assessment artifacts, as we call them. We will have a logbook and we will have an exam, and I will explain later on how these work exactly. Now, our tools for this module will be using Linux. So we like using a version of Red Hat Enterprise Linux 8, and this is the free version. Essentially, it's a project called Rocky Linux. All right, there's two of them. There's Rocky and there's Alma, and they're pretty much the same thing. It's just the logos that change, and they are both the same thing as Red Hat Enterprise Linux, minus the logos and the support from Red Hat. All right, we've been using this for ages. Give me a hands up if you've ever used Linux before in your life, please. All right, that's gonna be fun. So, one of the things that you have to learn how to use is you need to learn to use the operating system. All right, so it's okay. I mean, we will start from the beginning. The first lab sheet that we'll do will be the installation of the operating system on the system, and I will actually go through this lab sheet today and explain it to you. So that you have it on video and you can refer back to it before you come into the class next Friday. All right. And once you do the installation, I think because so many of you haven't used it before, I think I will upload another auxiliary lab sheet that contains some commands that you definitely need to know in order to be able to work with the operating system. Okay. And we will be using a cloud solution called Open Nebula. So it's an open source cloud solution. This Open Nebula and OpenStack are the only ones worth noting that are basically open source. Other cloud solutions like Amazon Cloud, or Google Cloud, and everything else, you need to pay a subscription and you need to do it on their web browser interfaces and all that. This one, you will need to install it on the computer, on the server itself. So you will learn how to install it, configure it, run it, and maintain it afterwards. Everything that you need to know about this module is located on Moodle. So the Moodle page is going to be your source of all information that you need about this. And because of this, it will only be your only source of material to revise for the exam as well at the end of the semester too. Assessments. Now, if we give me a second. Yeah, let's talk about the lab. So the lab that we'll be working on is called A2.net. So all of the rooms in the university are numbered. Okay, so A means Anglesey, 2 means second floor, and then you have various numbers like this is 226 or whatever it is. 2.net is special because it's our networks lab, and we convinced somebody at this stage to actually name it net and not A215, or as it should have been. That's fine. It's 3 hours per week in the lab with me and my teaching assistants where you can get help. However, the lab itself is open access. So you will get allocated one computer in there. So you will have one computer and a username on it. So it will be VM something. For you, it's probably going to be VM8. All right. And that computer and that username will belong to you. So you will basically change the password on that username to whatever you want it to be. And then nobody else will be able to use that computer and that username for the rest of the teaching block. All right. So you will build your system every week until you reach the end, which is completing all of the lab sheets and all of the work, and nobody else can actually mess with your system. So essentially, it's your computer away from home that you can experiment and install whatever you like on it, and it doesn't really matter if you make any mistakes. Okay. So it will be, of course, individual work. So it's one student per computer. There's 48 computers in the lab, and it fits up to 48 students. At the moment, I have 54 students registered in this course. So I've split it into 2 morning and afternoon sessions. All right. So your timetable will get updated sometime next week. If you're in the Computer Network Administration and Management course, you will move to the afternoon session, 2 to 5 o'clock. Okay. So keep it in mind. The other 2 courses will stay in the morning as they are now. Allocate computers user accounts, and of course, lots of people come and go in the lab. Please make sure that you keep it as tidy as you can. So the assessments for this module, we have logbook and we have exam. The logbook is the more difficult of the 2 to make. However, it's the one that always gives the students the most marks. So what you're supposed to do is you're supposed to come into the lab, do your work on your computer, take screenshots of everything that you do, and then have a logbook, which will be in electronic form, and put all your screenshots in there and explain what you've done step by step. Okay, this is it. I prefer the logbooks to be a Google Doc that you can create and you can access from a browser or anything. Okay, your university email addresses are Google Apps addresses. All right, so once you log in onto gmail.com, then you can basically go to Google Drive and start the logbook there. And I think in all honesty, we will do this on the first week. So next week when you come into the lab, I will have you all create your logbooks there and then. All right, before we actually start working on installing the operating system on the computer itself. And then you're supposed to take screenshots. There is a screenshot utility in the operating system, or you can do print screen, whatever you like. Take screenshots, put them in the logbook. The important details for the logbook, in order for you to get lots of marks for it, are that you need to have all the screenshots, first of all, but you also need to explain what is happening in those screenshots and why it's happening. So that will be so that you demonstrate that you're learning whatever it is that you're doing there. Okay. There is a video on Moodle that explains the structure of what the logbook should look like. Okay, it's a YouTube video, so you can watch it. I think it's about 8 minutes or something. It's not long, and it explains everything that you need to know about the logbook itself. Okay. So they're Google Docs. You will create them at the first lab. You will update them every week when you come in, and you will submit them at the end of the teaching block in May. I think it's something like the 18th of May or something like that. Okay, and you will get assessed on them. You will get assessed on them in class. So the last lab session that we will have, which I think is on the 18th of May, I think it's a Friday, I will come and sit with you on your computers, have a quick browse through your logbook, and have a look at your computer as well, and make sure that everything that you have on your computer actually corresponds to what you have on your logbook. I might or might not ask you some questions about it as well, okay, and give you a mark. The other item on which you will get assessed will be the exam. So that will happen in the exam period in May. So that's after the 20th of May or whenever it is. And it will be a 1-hour test that has 50 questions. They are fast questions, so you won't have to sit down and write down the story of your life or anything. Okay, they're usually multiple choice, multiple response questions, and so on. Time and location for this will be confirmed when the exam timetable comes out, and the material in the exam will be based on everything that is on Moodle. So it will have to come from both the lectures and the lab sheets that we give out for you in the labs. So, clouds. Clouds come from the idea of virtualization. So what is virtualization? Virtualization is the idea that you can take a computing resource and virtualize it, turn it from hardware into software. So you have a server, which is a physical box in a rack somewhere in a server room, and it has its own CPU and RAM and hard drive and network cards and everything else. And it has its own operating system that it runs, and it has some service that it runs inside it, like a web service or DNS or DHCP or whatever it is, and it provides a service to the public. Okay, the idea behind virtualization is that you take this server and you stick it into another computer. In fact, you take multiple of those servers and you run them as software inside one server that is strong enough to accommodate all of them. So you make virtual machines, which are computers running as software inside another computer, and they provide whatever services we want them to provide. Why is this useful? Because you can run multiple operating systems at the same time with pretty much the same resource. So one CPU with lots of cores can run multiple different types of operating systems depending on what services you need to provide and how you want to provide them. You have easier software installations, so if something goes wrong, it's just a software. You can just remove it, delete it, and start again. Testing and disaster recovery is very easy on this because it's software, and mostly because you can have snapshots and restore points. You install something, if you don't like it, you can just revert back into a snapshot and there's no problem with it. You don't have to format and reinstall the entire server. And one of the most important reasons as well, say it for last, is infrastructure consolidation. You don't need huge server farms and data centers in order to run a bunch of services. You can run everything inside the cloud, and in fact, that cloud doesn't even need to belong to you. You can rent some cloud space on a provider, and you can run a service on their computers and have them maintain it and service it. And most importantly, they take the blame if the service goes down and you lose money. Okay, which from a business perspective is awesome. But what's even more awesome than that is that the services will most likely never go down. We're talking about a very high availability of 99.999% of time and so on. Okay, so there are lots of benefits to it. Cloud computing comes from the whole idea of virtualization. So it's basically the on-demand availability of resources like CPU time or memory or networking even available to you from a resource that somebody else is providing or a resource that you are providing to consolidate all of your services and all of your systems across your company. Why is it useful? I won't go through all of this, but mainly it's because of efficiency, flexibility, and it gives a strategic edge to the company as well. Because it's software, it's much more configurable than having a hardware server running in one location physically, and you can basically make any changes that you want without it costing too much money, without it costing too much time. You don't need to employ so many people to manage this. In fact, you might not need to employ anybody to manage all of this if you're outsourcing it to another company and so on. So there are lots of benefits to this. So in the lab itself, what we will specifically deal with, so we have the unit intro, which is today. We have design and installation considerations, which I will go through today as well, I'm hoping. All right. We will build our first virtual machine. So we will install the operating system and the environment. So in the first week, when you come in next week, I think I will take it a bit slow for the first week, and I will only give you the installation of Rocky on it. So we will install the operating system that we will be working on. The way that this works is a bit tricky, so I will explain it once I get to the lab sheet later on today. Okay. So we'll install the operating system, we'll install the environment, which is OpenNebula itself, so the software that we need to use. We'll build our first virtual machine. We'll play around a little bit with the web interface that manages the cloud and look at all the settings and everything else that we can do with this. We'll install networking, so we'll configure something called Open vSwitch in order to give us full access to all of the networking capabilities of the cloud. And in the end, we will actually build a bunch of virtual machines that will basically make up your cloud system. Okay. Essentially, these are titles of the lab sheets pretty much. The last lab sheet is supposed to last 4 or 5 weeks. So it's a big assignment sort of thing. Okay. More on this later on. Recommended reading for this. So because you haven't used Linux much, it's very, very important that you practice a little bit with Red Hat based operating systems, with Red Hat Linux. Okay, so when we go into the lab next week and we install the operating system, as I said, I will give you another lab sheet with a few of the commands for you to try out as well. Okay, and you can also have a look online and read about Red Hat Linux 8, which is the most important item of this. And also we have the Open Nebula documentation website, which is basically the manual of the thing. And everything that you might need to ask a question about, it will definitely be answered there. The documentation for this is extremely good. All right. Do you have any questions about the module itself so far from what I said? Yeah. So it will run from now until end of May. 2 artifacts to do, logbook and exam. You keep the logbook during the lab and you do the exam at the end of it. You work on your computers. Each computer is your own as you sit on it. So obviously this means that when you choose a computer, when you've come in the first day, you need to stay on that same computer and come and work on the same computer with the same username every week. Yeah? Until you complete all of your work that you need to do. So what else do we have? Yes, so the documentation website for Open Nebula looks something like this. All right, so it has a quick start guide and everything else that you might need, so you can go through it and have a look. What I do want to explain, definitely before next week, is how do we actually use our computers in the lab. So, the computers in the lab are already built with Rocky Linux 8. Okay, so the operating system physically on the hard drive on the computer exists and it's installed. You will log in with whatever username we allocate to you on the day. It will be VM something. And when you log in that computer with that username, you don't have root access. Okay, you are a normal user. Because everything that we will do will require us to have root access, and for the reasons that you can have backups later on, we're doing everything inside a virtual machine itself. So, when we install on this first week our Rocky Linux, so that we run our cloud inside it, we do it on a virtual machine. We use VMware Player, okay, which is one of the oldest virtualization hypervisors around, okay, and the most well known. And we install a Rocky Linux installation inside VMware Player. We give it, I think it's 8 cores and 32 gigabytes of RAM, which should be plenty to run your cloud. And you run the operating system inside it. You then install Open Nebula inside that virtual machine. Basically, everything that you do past the installation happens inside that virtual machine. Okay, you don't do anything on the host itself. All right. The biggest benefit of this all is for us that we can have multiple users on this computer, because we do have lots of students that go through this lab. But for you, the biggest benefit is that at the end of each week, you can make a copy of this virtual machine onto the hard drive, so you can take a backup. So if you complete lab sheet 1, you take a backup of it, and then next week you move on to the next lab sheet. You mess up your computer completely, it doesn't matter. You can just restore it from the previous week's backup. Okay, and this is something that's proved very useful, especially in the last couple of years. All right, so how do we do this? We will have a virtual machine. The virtual machine will be called Prometheus, and then your student number will be in front of it. So it will be UP and then your student number dash Prometheus. This is very important because this way we can tell which virtual machine belongs to which student. Yeah, because it has your student number on it. So, how do we go about this? You log in onto the system with VM, whatever username we give you. The password is always localhost 1. Okay, and you can basically start and get to work on this. So when you log into the computer, the first thing that we will want you to do will be to actually change your password. Okay, so that nobody else can type localhost 1 and accidentally log into your computer and work. Okay, so there's a command, you just open a terminal, type passwd, we'll explain to you in the lab, and you change the password to something that you know, only you know, and remember, hopefully. Every semester people forget their passwords, it's brilliant. So when we come in the second week, I have a running bet with my teaching assistants of what sort of number of students will forget their password. Yes, I always go for the lowest number, so please, help me win this year, yeah? Remember your password from next week. So, we start VMware Player, we choose to create a new virtual machine. You use an ISO image, so we download an ISO image of Rocky 8. It will be on your system already, as an ISO, as a DVD essentially. You connect that onto the virtual machine. You set up the name of the virtual machine to be UP student number dash Prometheus. And then you give it some hard drive space. The hard drive space for this is going to be 400 gigabytes. This should give you plenty of space to run lots of virtual machines inside it that are 20 or 40 gigabytes each. Okay. We give it 32 gigabytes of RAM, we give it 8 CPU cores, so this is all now happening in the settings of VMware Player. Okay, so this is already virtualized. Alright, so 8 CPU cores, and we set the network adapter to bridge and disable the 3D acceleration from the display because sometimes it gets glitchy if you don't. And then you are ready to basically begin the installation of the virtual machine itself. The bridged networking mode on this means that your computer that you're building, Prometheus, will be on the same subnet as the rest of the computers in the lab. So the university owns a Class B network, 148.197.0.0. Okay, it's a great privilege and waste of IP addresses, but we were here first back in the early 90s, and one of our system admins, Philip True, when the IP addressing scheme came out, thought, that's a good idea, let's get one of these. So he got an entire Class B. So we have it. It's awesome. This means that we can actually use public Class B IP addresses on our networks everywhere. All right. So the university owns 148.197. The lab works on 148.197.28.0. Okay. So we are on what we call subnet 28. So the IP addresses of the computers in the lab are 28.1 to 28.48. These will be the IP addresses of the physical computers, of the hosts that you're working on. So, your IP addresses for the virtual machine that you're building will still need to be on subnet 28, and we'll need to figure out a way for you to give all IP addresses to your computers without having any conflicts, without having duplicate IP addresses. The rule that we use for this is the +50 rule, as we call it. Okay, so if your host has an address of 28.9, then your Prometheus virtual machine must have an IP address of 28.59. Okay, so this is the first level bridging, as we call it. When you build your cloud later on, you can create virtual machines inside your cloud, which are located inside Prometheus, which is located inside your host. So this is what we call nested virtualization, yeah? Virtual machines inside the cloud, inside the virtual machine. It's fine, you can do this, trust me. And you can bridge it again. So this would be a second level, so you do plus another 50. So that host would have an IP address of 109, 28.109, okay? So we do this, and we have a couple of other tricks for the IP addresses down up our sleeves as well. I will explain it later on the OVS networking website what we do. So bridge mode means that you're on the same network, on the same subnet as your host. So we go on with the installation of the operating system. We set the localization to English UK. This is important for the keyboard, so that the @ and the hashtag are on the same place as the keyboard. So that's why you need to make sure that you change it from US to UK. Set the location and everything. And the first important thing that you need to check is software selection. So, okay, hands up if you've installed Windows 10 or 11 or 8 in your life before. So when you install Windows, you install Windows. Yes, install it and it says, bam, okay, I will install. Linux is different because it has different types of installations that you can perform. You can perform a server installation, you can perform a workstation installation, you can perform a minimal install, and so on. So it's very important for you to choose server with GUI, server with GUI. All right, and in that server with GUI, you need to go to the other side as well. So it will be two tables, and you need to choose those services as they are here. If you don't choose those services, we will reach a point in the fourth lab sheet that something will not work, and there's nothing I can do about it. So you'll have to rebuild from scratch. So very important that you set this right. Okay. Once you choose the software that you want installed, we need to partition the hard drive. So we have 400 gigabytes of space, and by default, the system will create a partition table. It will contain the slash, which is what we call the root partition of the hard drive. It will call another partition, which will be the slash home. It will have a slash boot, and it will have a swap partition as well. The slash boot holds the operating system kernel. So it holds the main program that runs the operating system. It's isolated in that partition so that it's safer that way. We have the swap partition, which is an extended memory, an extended RAM for your system. So if you run out of RAM, the system starts using the swap space. It gets slower, but it doesn't crash to death. And you have the slash home partition, which take up most of the hard drive space on your hard drive, because that's where all of the user information is stored. Okay, so all of the home directories for your users are there. However, because we are in a lab environment, and because everything that you will be doing will require administrative privileges, you will never actually log in as a normal user onto this system. You will always log in as root. The guideline in Linux is that you never log in as root, you always log in as a normal user, and if you need to do anything to administer the system, then you switch user and you go up to root. With increased privileges, you do whatever you want to do, and then you log out again. Because this is a test lab environment, and we don't need all of this faff of SUing all the time, and it will be all the time. You will be logging in as root. Because you will be logging in as root, the root's home directory is not in slash home, it's in slash root actually. So we don't need this slash home partition, and the slash home partition is the biggest one in the system. So we delete it. Okay? So we delete the slash home partition, and we allocate all of the remaining space onto the slash partition so that our root user can have enough space to run whatever they want. Alright. Once we do that, we go on to the networking side of things. You need to set the host name, and the host name will be up student number -prometheus.netlab.e.port.ac.uk. UK because we're in the UK, AC because it's academic, we're a university, so we belong to Janet, which is the ISP that provides us with our internet, and then port because we're in the University of Portsmouth, so that's our DNS servers. EE is electronic engineering, and this is a legacy thing that we're keeping for back when I was a student here 25 years ago. Getting old. Anyway, yes, so electronic engineering, that's what this stands for, and this sorts out all of the addresses in the second floor of Anglesey essentially now. Yeah. Netlab is a2.net, so that is the domain that we're working with, and then you have the name of the computer itself, which will be up something Prometheus. All right, so it all means something, and it has to do with DNS and everything else. All right, so the domain that you will be working on is netlab.e.port.ac.uk. Once we do that, we sort out the IP addresses. So we have 28.something, where the something will be your IP address plus 50, as I explained earlier. We will then have a subnet mask that we need to use. The subnet mask that we need to use is a custom subnet mask, and it's a 23-bit long subnet mask. And this is now getting very geeky, and I will explain this in much more detail later on. All right. So a default class C subnet mask is 255.255.255.0. However, because we want to have as many addresses as possible, and we have lots of addresses to play with, we've taken away one of the bits from that subnet mask, and instead of a 24-bit long default subnet mask, we use a 23-bit long subnet mask. This allows us to do what? This allows us to have not only subnet 28 for the lab, but we have subnet 29, which is after it as well. So one Class C subnet can fit 254 computers. We can fit 508 computers in this. Okay, so when you're bridging, for example, and you go 2859, 2809, 2959, you can actually go on to 29.9, 2959, 2909, and so on. So it's all in the same neighborhood, everything works and everything pings each other and so on. Okay, this is why this is. Our gateway in the lab is 28254. It's our Columbus computer, which acts as a gateway / nothing server / firewall. So the lab itself is really isolated from the outside world. There is nothing you can do in the lab that will affect the university network, okay? Because we do play with routing as well, and you will install routing later on into your cloud and so on. You can't really mess it up for anybody else. So, right. This also means, of course, that you cannot access the lab from the outside either. Yeah. And we have our DNS servers, which is 28251, which is the one that we have on our floor here, and then we have 8.12, which is a secondary university server. The domain, as we said, netlab.ac UK. So once you set up the networking, you then basically have user settings. So you set the root password to localhost 1, and then it will ask you for another user as well. You create a user, you can name it whatever you like, never log into it. All right. So it will restart the system, it will ask you a couple of things, license and so on. It will log in as that user that you created, log out, log in as root, and you're ready to use the virtual machine that you just created. That machine itself, we need to learn how to take a backup of it. It is a virtual machine, so it's software. As software, it lives as a bunch of files on the operating system of the host. All right, so on the host, there's a /VM whatever /VMware folder, and in there you will find a folder called UP your student number - Prometheus. So that folder contains all of the files for the virtual machine that you just built. All you need to do to take a backup of your virtual machine is, first of all, make sure that your virtual machine is powered off, and then just copy that folder next to it. So you will have your UP Prometheus, make a UP Prometheus backup, and that's it. You have a backup of your virtual machine on the first lab, and do this on the first lab so that if anything goes wrong later on, you can revert onto the original backup of the system itself. Once you do the backup as well, I do want you to play around a little bit with the operating system. So there are a couple of things that I want you to do. Because we will be using Google Docs, the best compatibility, surprise, surprise, is provided by Google Chrome. Google Chrome by default is not included in the operating system installation, but you can install it. You can install it fairly easily. However, because you're logged in as root, it will refuse to run. So this will be your first test / challenge of figuring out how to get stuff working. Okay, it is fairly easy if you know how to do it, and it is not too difficult to figure out how to do it either. So we won't give you any instructions on this. Bonus rounds usually don't come with instructions from us. We just order you to do things. Yeah. You need to go online and search and figure out how to actually do this. So first, you need to figure out how to install it. Just go to google.com. How do I install Google Chrome on Rocky? Okay, it will come up with installation instructions. And then once you do that, go and ask it, how do I get the thing to run as root? And it will tell you again. All right. I do expect you to be able to troubleshoot stuff. There will be me and 3 teaching assistants in the lab, and our job is to help you. All right. However, it's more important for you to learn how to get things working on your own. All right, because later on, when you go to work somewhere, nobody's going to help you. All right. And most importantly, your employers will expect you to be able to figure stuff out on your own. Yeah? Yes, there might be somebody there to help you, a more senior system administrator or network engineer or whatever, but you don't want to pester them all the time. Yeah? You want to be able to show initiative, and it's one of the skills that you're supposed to have when you graduate from university. All right? You should be able to get things working on your own. All right? So get Google Chrome working, and the next one is playing around with the operating system a little bit. sorting out the shortcuts on the desktop and so on. So you can try and again search and figure out how to get this working. When we get to that lab session, to the first lab session, I will also ask you first of all to log in, change your passwords, and then create your logbooks as well. I will show you on the projectors how to actually take screenshots and what I want your screenshots to look like on the system. Okay, so I do want your logbooks to be started on that very first day before we start doing anything else. Because I want you to start taking screenshots from the very beginning of installing the operating system and creating your Prometheus virtual machine. All right. So at the end of the lab session, there is a reason why I'm going to take this slow, because I could have given you the Open Nebula installation lab sheet as well, which is the next one. Okay, but I don't want you to rush through the material. I want you to learn how to work in the first week, and then basically get on with the rest of the stuff from that one. Okay, so they are 3-hour lab sessions. You can leave earlier if you're finished with everything and you're happy with it. Okay, but I definitely want you to be there in the beginning of the session, because usually I will do a recap of last week's lecture and remind everybody what it is that we're doing on that specific week. Okay, so please make sure that you are there on time, and then you can come and go as you please, I don't mind. So the lab itself, as I said, is open access. And if you think that your 3 hours per week in the lab are not enough for you, or if you're stressing anything, you'd like to move forward to the material and cover it sooner, you can come into the lab and work whenever you like. So if there's no lab running, go to your computer. If it's free, just sit on it and work. The lab is open from 8 o'clock in the morning until 8 o'clock in the evening. If there is another lab running, but there's still nobody else sitting on your computer, you can still go in and work. Just make sure that you set your phone to silent, please, so that you don't bother the rest of the class, because they might be having a class and so on. Okay, so you can still work. And when we get towards the end of the semester, when everybody will be panicking and everybody will want to work in open access, don't hog the computer. So if you're working on open access, somebody comes and says, I want to use this too, give them an hour, tell them to come back in an hour, and then just, let them use the computer as well. Okay? And come back after 5 minutes so that they have to give you the computer back in 1. No. Anyway, so yes, this is generally how we work in the lab, okay, and how the module itself runs. I don't really have time to go through the next one that I wanted, which is explaining how Open Nebula works. So I will keep this for next week. All right, you can have a look at it if you like. It is on Moodle, so it basically explains the architecture of Open Nebula and how a cloud and most clouds work. And we'll go through this next week. Okay, a lot of information, and it's very abstract at the moment because you're not on the computer. So, if I'm telling you how to install the operating system and you're sitting on a desk. However, if you watch this once before next Friday and you come in and freshen everything up, when I explain everything in the lab and when things happen to you in the lab and you need to figure out how something works, it will be easier for you to figure it out. Okay? Any questions about all this? All right, see you next week. Thank you very much.